Greetings out there in YouTube land. Today's video is going to cover a topic that comes up over and over again in your questions and comments, and that is how to convert a PA amp into a good functional guitar amp. And as test subjects, on my recent travels through Central Texas, I picked up a pair of these Model 106 J.W. Davis PA amplifiers. These little amp heads are absolutely perfect for conversion to guitar amp use. As you can see, they have a very attractive wooden cabinet, good ventilation for the tubes, an attractive control panel with volume controls for a microphone input, music input, and also tone control. This is the input here for the microphone. Here's the rear view with the fuse, all sorts of impedances for different types of speaker or speaker systems, a phono input, an absolutely monstrous power transformer and output transformer. After removing 4 screws from the wooden cabinet, we can lift it off of the chassis and see the tube complement, a pair of Amperex 6BQ5 output tubes, similar to a Vox AC15. We have a 6EU7 Gibson style preamp tube, which is a dual triode, much like a 12AX7, and a 6CA4 rectifier. All are original vintage tubes. When I see a little tag like this, it makes me like these even more. Seems we share something in common. Both the amps and I are from Texas. It should be mentioned that although the conversion procedure in this video will be directed at these specific amps, the principles and practices that will be demonstrated are applicable to probably 98% of all the PA amps that you will ever encounter. So without further ado, let's take a look at the schematic of these amps, see what type of circuits they have, and what types of modifications will be required. Okay, let's take a look at the schematic of the Davis Model 106 amp. First off, there's 3 inputs: the low impedance input, microphone input, and phonograph input. The microphone input feeds into the grid of one of the 2 triodes in a 6EU7 preamp tube. The plate then feeds through this coupling capacitor and through the microphone volume control into the grid of the second triode of the 6EU7. So we have 2 stages of amplification if we plug into the microphone input. If we plug into the phono input, however, we have a dedicated phono or music volume control here, which feeds only into the second stage of the 6EU7. So using the phono input, 1 stage of preamplification; using the microphone input, 2 stages. I think for our guitar amplifier conversion, the microphone input's the way to go, with 2 separate stages of preamplification. Then the signal will proceed through the 0.01 microfarad coupling capacitor, past the tone control, which will bleed off more or less of the treble frequencies, and then into the grid of the upper 6BQ5 output tube. Notice also that here there is a output jack for the preamp stages. So those of you who want preamp output to use a separate power amplifier, this would be the way to go. Now as we look here at the 2 6BQ5 output tubes, there's something conspicuously missing, and that is there is no phase inverter tube or transformer. Instead, the phase inversion occurs much like it did in the Magnatone Melodier circuit. Notice here the screen grid of the upper 6BQ5 is connected through a coupling capacitor to the first grid or signal grid of the bottom 6BQ5. Recall also that the signal on the screen grid and on the plate are inverted with respect to the grid 1 or signal grid. Okay, so this is an inverted signal and it's of much lower magnitude than the plate signal. This inverted screen grid signal then is going to be sent down here to the input or first grid of the lower 6BQ5 and drive this tube. So the phase inversion then occurs between the screen grid of the upper tube and the input or signal grid of the lower tube. Why is this done? Possibly to save money, one tube, one socket, or a transformer. However, as you'll see, it works very well, so you really don't lose much by using this method. Also look here then, our 6BQ5s are cathode biased and bypassed. Then they both feed into a rather complex output transformer. The primary is the standard center tapped primary winding, but the secondary has many different impedance and voltage output taps, and this is fairly typical of PA amplifiers. Since you may already have a speaker system wired into the building, they want this amp to be able to work with whatever speaker system you have installed. You have between the common or black lead, which is grounded, you have a 4 ohm output, an 8 ohm output, 16 ohm, 25 volt, or 70 volt for PA constant voltage types of speaker systems. For our guitar conversion, we are going to utilize the 4, 8, and 16 ohm outputs. And one really snazzy feature of this circuit is, if you look down here at the 6.3 volt filament output from the power transformer, we see the center tap, which is almost always grounded, right? But look what they've done with it. They bring it up here and connect it to the cathodes of the output tubes. This is a fairly common modification to reduce 60 cycle hum in amplifier circuits by elevating the 6.3 volt heater circuit above ground. In other words, not connecting it to ground but to a voltage higher than ground, you greatly reduce the tendency for hum to occur. Well, it looks like Jack wants to go out in the garage, and you'll be very amused by what he does when he gets out there. Okay, Jack, here we go. For some reason, he just loves to go out and roll around on the cement in the garage. You know, I couldn't figure out why until I tried it myself, and I gotta admit, it is absolutely exhilarating. Now, a few areas where I think we can improve the tone of this amplifier. Number one, notice that the 0.01 coupling capacitors here and here are disc capacitors, which are not known for great tone. So I'm going to try some 0.02 more conventional spray capacitors in these positions. Another place where modification might be indicated is right here. Notice there are no cathode bypass caps on either of the two triode input stages. We know that adding bypass caps here and or here will increase the overall gain and the frequency response of these stages. Another area of concern is this 82K resistor here, which is going to allow a lot of our signal to take a shortcut to ground. I don't really understand that. Maybe it's to reduce the possibility of distortion if the gain is cranked up too high here in the preamp stage. But let's face it, that's exactly what we want. So I'm going to try this with and without the 82K resistor in place. Then finally, I'm going to check the bias of these output tubes. Whether or not 150 ohms is ideal or not, I'm not sure, but we'll check and see what the plate dissipation is in each of these tubes. Also, a tip of the hat to MB Setzer, who took the time to draw this schematic and post it on the internet so that we could access it. I wish there were more people like him because we need all the schematics we can get. Okay, now that I've flipped this little jewel over on its back, we'll pull off this base plate with the 4 original rubber feet. Take a look inside at the absolutely immaculate point-to-point wiring. This looks like a splice, but it's not. It's a way to tie this particular lead to the red and yellow stripe lead to keep it out of trouble so it doesn't flop around in here and ground out. Cord still has the original repair tag on it. I have no idea if the repairs were done or not, but it sort of halfway conceals a real problem, and that is that the original zip cord here is has the insulation peeled back and it's a dead short. So let's go in and replace this power cord. Okay, step 1 is completed. The black hot wire goes to the power on-off switch, white goes to the fuse and then to the transformer primary, and the green grounding wire is securely bolted under one of the transformer nuts. Fortunately, we already have the input jack for the guitar cord. We're going to use the microphone input, and otherwise we would install a grounding input jack and then use shielded cable to run to the grid of the first preamp tube stage. However, we don't have an output jack, so I drilled a hole in the back of the chassis and installed a jack for my speaker output cord. I strongly suggest using an ungrounded output jack for the speakers because inadvertently grounding your speaker output would destroy your output transformer. I didn't have any ungrounded jacks available, so what I did is I bent the blade away, and then you leave the lead that goes to that grounding blade alone. You do not ground it. Then I soldered a wire to the switch lug that does connect to the main contact blade and ran the wire through a hole in the lug strip. Then you run the wire outside here and crimp on a spade terminal to the end so it can be screwed down by the 4 ohm screw or 8 ohm or 16 ohm depending on the speaker or speakers that you intend to use. The common is grounded to the chassis, and the speaker jack is also grounded to the chassis. So this contact is made through the chassis, but the contact to the blade, the output blade of the speaker jack, is made through whatever of these terminals you connect the spade to. Since my workshop speaker is an 8 ohm, I've connected to the 8 ohm terminal. I doubt seriously that you would ever have any use for any of these terminals. And that's why I removed one of the screws and used the hole to pass the wire through. So now we've got a good 3-wire grounded cord. We've got a speaker output jack that's set to 8 ohms, and we've got our microphone input jack that goes to the grid of our first amplification stage. So now let's plug our amplifier into a current limiter, plug a guitar cable into the microphone input, and hook up a 8 ohm speaker to our speaker jack. Turn this thing on and see what happens. Okay, we're all plugged in here and ready to go. But first, there's a word of caution. If you have a guitar plugged into an amp with an open chassis like this, do not touch the guitar strings with one hand, which are grounded to the chassis of the amp, and touch anything in the amp with the other hand, or you could be in for a potentially fatal shock. Okay, I've got the microphone volume and the tone both at a setting of 5 out of 10. Okay, let's play a few chords and see how it sounds. Well, it's got a really full tone with a lot of volume, but it seems like it's a little blubbery to me and might be missing a little treble or high end, a little clarity. Well, since volume's not an issue, the tone does seem a little dirty to me. Let's change out those disc capacitors. Okay, they're just notorious for having poor tone. Let's see how it sounds with them changed out. The 3 disc capacitors have been removed and replaced with 3 tubular capacitors, hopefully of much higher quality. So let's plug it all in and see how it sounds. All the settings are exactly the same. Well, it still sounds a little blubbery at the low end and a little weak at the top end. So now let's try it without that 82K resistor that effectively jumpers the tone control. Okay, I cut one leg of it here and lifted it away from the tone control lug. Pretty much the same. Okay, I tried adding cathode bypass caps to both triodes of the 6EU7, and surprisingly enough, that made almost no difference at all, so I haven't added them to the circuit. I did notice something interesting though. If you plug into the phono input, there's a 330K grid stopper resistor protecting the grid of the second triode of the 6EU7. But if you plug into the microphone input, it goes straight into the grid. Okay, there is the grid leak resistor here, but you notice there is no grid stopper at all. Okay, I've set up a little experiment here where I can now insert a 68K grid stopper resistor in series between the microphone input and the grid of the first triode stage of the 6EU7. So I'm going to strum a few chords with and without the 68K grid stopper in place. Let's see if it makes much difference. If it does, then I'm going to add it to the circuit. Okay, here's a chord with the grid stopper in place. Sounds good to me. Good bass, mid-range, and treble. Now we'll try it with the grid stopper bypassed. Oh, it sounds hideous. Real boomy and not a pleasant type of distortion at all. So it looks like the grid stopper is going to get soldered in place. Kind of an odd problem has arisen here. Everything's sounding really good, and then distortion begins, and not the good type, and the volume fades away to almost nothing. Turns out the problem is caused by the fact that 3 of the 4 6BQ5s in the 2 amplifiers are bad. Now they test just fine on a tube tester, but when they're warm and in use in the amp, the plate current is unstable within them and they do just what you heard them do. So now I have one original 6BQ5 and then one NOS Raytheon tube that I happen to have in my stash. Now, in my never-ending efforts to measure Rusty's great intellect, we're going to give him a choice here between savory dog food, specially made just for him, and an opportunity to express his great disgust for his nemesis Jack and the cat food that Jack likes to eat. As you can see, I'm having to hold him back from his dog food. Here he goes. Rusty, that's the dog food over there. That's Jack's food you're eating. Oh. And here's the end result of our test. Okay, let's take a look at what was done to convert this PA amp into a guitar amp. Number one, we installed an output jack for the speaker and wired it in such a way that we could connect it to either the 4, 8, or 16 ohm windings of our output transformer. We took advantage of the fact that an input jack already existed. It was rewired to include a grid stopper resistor of 68K. If this jack had not been present, we would have had to drill the chassis and install one, and then wire it through the grid stopper resistor to the grid of the first preamplifier tube. Those nasty old disc capacitors were all replaced with tubular capacitors, and I replaced this 0.1 microfarad coupling cap with a new tubular cap. The one good original 6BQ5 is in this socket over here is the new 6BQ5, which solved that strange problem that I discussed. And finally, we have our 3-wire power cord with the chassis securely grounded with the green wire bolted under a transformer nut. The electrolytic capacitors all checked out okay, so I'm going just with the original can cap. Okay, that's about it. Let's flip it over, hook it up, and see how it sounds. Then if you turn up the volume just a little bit more, it really starts to break up nicely. Well, that's about it for this video on the conversion of the Davis Model 106 PA amp into a guitar amplifier. Anyone who's ever ordered parts to scratch build an amp knows that it's a very expensive proposition. The components in either one of these small amplifiers would probably cost probably $400 to $500 to purchase new. And yet these are vintage components of very, very high quality, including the tubes, of course, for a small fraction of that price. You can buy these on eBay for probably $100 or less, and then convert them into just a dynamite little vintage tube guitar amp, or cannibalize them for parts for your scratch build. Today we discussed how to do the conversion to guitar amp. I hope you enjoyed it, and I hope to see you again soon in the near future. Bye from Rusty and me.